Hello everyone. Today I will solve LeetCode 3371, identify the largest outlier in an array. In this question we are given an array nums. This array contains n elements where exactly n-2 elements are special. One of the remaining two elements is sum of the special numbers and the other is an outlier. Here outlier is a number that is not in special numbers nor it is sum of those elements. So it's a totally different number, a single element in the list. Our task is to find the largest such outlier. So there can be multiple outliers that fulfills the requirements in the question and we need to find the largest of them. To better understand the question, let's look at the first example. 2, 3, 5 and 10. So here one valid way to find an outlier here would be choosing 10 as the outlier. If 10 is the outlier, then 2, 3, 5 includes special numbers and sum of special numbers. Here we can choose 2 and 3 as special numbers and 5 as sum of special numbers. So this is a valid separation of numbers into these three groups. And 10 is a valid outlier. And also 10 is the largest element in this array, so 10 has to be the answer. Let's look at the second one. We have -2, -1, -3, -6, and 4. Let's check if -2 can be an outlier. If we consider this as an outlier, we can actually find a valid split where -1, -6 and 4 are special numbers where their sum will be -3 and -3 exists here, so this will be the sum element. So -2 is actually an outlier, but it's not the answer. The answer is 4 because 4 is also a valid outlier and it's the largest outlier. Now that we understood the question, let's think about how we can approach this problem. Instead of thinking about data structures and algorithms, we can first think about how we will solve this question using just a pencil. Let's use the first example again, and a simple approach on this example will be just choosing the first number as an outlier and see if the rest of the numbers can be divided into special numbers and their sum. So we have here 3, 5 and 10, and these numbers has to include both special numbers as well as their sum. If we name the sum of special numbers here as x, and if we sum these numbers here, 3 plus 5 plus 10 is 18. This 18 is actually x because we here basically sum special numbers, that's an x, and their sum, which is also x. So 18 here equals to 2x. What does this mean? We can make two observations here. First, the remaining numbers are divisible by 2. So since they are sum of all the special numbers and also their sum, it has to be divisible by 2. Another observation we can make is half of the remaining numbers, that is x in our notation, has to exist in list. If we think on this example again, the half of 18 is 9, but 9 is not here. We have only 3, 5 and 10. That means that 2 cannot be an outlier. So this is a way that we can use to verify that if a chosen outlier is actually an outlier. And by this way we can iterate on the array and check if this number is an outlier. And after that, all we need to do is keep track of largest outlier that we have encountered. Let's look at the last step of the execution on this example. If we designate 10 as outlier, then the sum here is 10 and half of it is 5, which is here. So this has to be sum of special numbers, and 2 and 3 will be special numbers. So here we see that 10 is actually a valid outlier because 2 and 3 are special numbers. Their sum is 5. 5 exists here, that's the sum element, and the 10 is outlier. And since 10 is the largest element, 10 is answer. So this is how we can approach this problem, and now that we have an approach, let's code it. Alright, let's start coding. We first need a total variable where we store the sum of nums, and a counts variable. I will use counter for this for simplicity, and we will use counts for checking if the sum of special numbers is actually in the list. Outlier will be our result, and I initialize it as minus infinity. Now I iterate on nums, and for each of these num elements we will first calculate remaining sum as total minus num. Now this has to be special nums, their sum, and I will decrease counts num by 1 because num is now considered as an outlier, and we need to exclude it from counts because we will check special nums using counts. If remaining sum is divisible by 2 and also count of remaining sum divided by 2 is greater than 0, then it means that we found an outlier. So num was actually an outlier. Now we can update variable outlier as maximum of outlier and current num, and we need to increase counts num by 1 to fix it to its real value before the next iteration. And we just need to return outlier. That's all actually for coding part. So what do we do here? We first get the total, that's the sum of all the elements here, and using counter we get counts. This will give us a dictionary where keys are distinct values in nums array and values are their counts. An outlier is our result variable. We initialize it from minus infinity, and then we iterate on all of these numbers, and for each of them we will first calculate the remaining sum excluding the outlier. It has to be the special nums plus their sum, and we will decrease count num by 1 because now we are excluding it from counts because it's the outlier, and then remaining sum has to be 1 divisible by 0, and 2, its half has to exist in counts array because it's the sum of special numbers. And now we can update outlier as maximum of existing outlier and current number. And finally we have to fix the counts num by increasing its value by 1 before the next iteration. Now we can actually verify our implementation by using an example input. So let's check what happens when we execute our code here. So total here will be 15, and counts will look like, so this is a dictionary where we have key 1 and count is 5, and for 5 the count is 2. Initially outlier is minus infinity, and then we start our iteration. First we check this first value 1, and for this one the remaining sum will be 14. It's total 15 minus 1, it's 14, and 14 is divisible by 2, and the result is 7, but 7 doesn't exist in our array. We know this by checking counts. We don't have 7, so this can't be an outlier, and this will be true for all the ones here, so we can just jump to 5. For 5 the remaining sum will be 10, and now we need to check if half of this value, which is 5, exists in our array. And we can do this check by looking at counts, and we see 5 here. Since 5 exists here, of course this will first be decreased by 1, because 5 is now considered the outlier, and we first decrease its value here, so it will be 1. And when we do the check here, we will see that we have 5 and its count is greater than 0. So it means that 5 is an outlier value, and outlier here will be updated as 5. And the same thing will basically happen with the last element, which is also 5, and outlier will not change, it will stay as 5. So the result here will be 5, and this will work because if we consider 5 as outlier, then the remaining numbers will be these ones and the last 5. So the special numbers here will be ones. We have 5 of them, and their sum is 5, which is also here. This is the sum element, and the outlier will be the other 5. So we verified that our implementation works as expected. Now let's move on to time and space complexity. If you consider the time complexity of the solution, we see that it's an ON solution, and the reason is we have here sum on nums, which is an ON operation. Counter also checks all of the elements in the nums, it's an ON operation. We iterate here on nums, which is an ON operation, given that the operations inside the for loop is constant, and it's actually the case because we have some mathematical operations as well as bunch of dictionary key accesses, which is O1 constant on average. So the code block here will be O1 constant, and the overall complexity because of these iteration is ON. So at the end we will have ON time complexity. For space complexity, we need to check our auxiliary space. We have some constant space variables such as total, outlier, but counts is not a constant space because we basically create a dictionary of all of the distinct elements in nums, and since the number of distinct elements in nums is bounded by all elements, because all elements can be different and we can have as many as the number of elements in the counts as keys, so it's bounded by ON. At the end, space complexity will be ON. Alright, so that's all for this question. Thank you for listening. If you have any questions or comments, I appreciate them. See you in the next video.